This is Anthony here, and welcome back to our walkthrough of the Nico 150 problems. I know we've been off for the past couple months. Had some stuff happen. Got pretty sick and needed to take care of myself. Then I had to go back to school, and things got a little crazy from there, but I'm officially back, guys. And I'm very glad that I am back at work and ready to do some more problems. So, where we left off, we were talking about like 2-pointers problems. We started with an easier one, but we're going to move on to a little bit more difficult one this time around. So, there's actually a couple ways that you can solve a workbook, but either way, we're going to show why 2-pointers is the best solution for this problem. So, let's take a look at this problem. So, it's 2 sum 2. The input array is sorted. Alright, so given a 1-index array of integers, numbers, that is already sorted in non-decreasing order, find 2 numbers such that they add up to a specific target number. Let these 2 numbers be numbers index 1 and numbers index 2, where 1 is less than or equal to index 1, less than index 2, less than or equal to numbers.length. Return the indices of the 2 numbers added by 1 as an integer array of length 2. The tests are generated such that there is exactly one solution, and you may not use the same element twice. And your solution must use only constant extra space. Alright, so that's why. Alright, so the 2-pointer solution is actually the only solution that I can think of that actually uses a constant space complexity. Minus the brute force solution, but that is a gap. We're still going to talk about it, but it's worth mentioning. All right, so we got a few examples. So you have numbers 2, 7, 11, 15 with a target of 9. We have a sum of 2 and 7 that is 9. These elements are found at 0 and 1. However, we are adding 1 and 2. Alright, so to clarify, looks like the indices are going to be 1-based indexing when we return a result, versus when we typically use 0-based indexing for programming. Alright, so we're going to make sure we keep that in mind. Alright, and then for another example, we have 2, 3, and 4, target is 6. Next. And then 2 and 4 sum to 6, so the indices 1 and 3 in this case. And they are going to be in one array, looks like. Alright, anyways. Example 3, this is the last example. Number is -1, 0. Target is -1. Output's 1 and simply 1, 2. Alright, and then remember, there's a guaranteed single solution for each input array, so we don't need to worry about those edge cases at all. Constraints: 2 is less than or equal to numbers.length, less than or equal to 3 times 10 to the 4. 30,000. 30,000 numbers. Yikes. Alright, and then each number can be between 1,000 and -1,000. Numbers are sorted in non-decreasing order. The target is also going to be in between -1,000 and 1,000. Tests are generated such that there is exactly one solution. Okay. Alright, so without further ado, let's get started. Alright, so I'm going to write out my little note space here. And we're going to start drawing out the plan. Alright, so I think we're going to start with the brute force solution, which is pretty easy to understand. Of course. So we got to loop through the numbers. We're going to use index I. Okay. And I just forgot. Remember that I have to label to number these. Okay? And then we loop through numbers starting at index I plus 1, just to avoid repetition of pairs, basically. And in this loop, we're going to use index j. Okay? All right? And then we want to check to see if numbers at index I is plus numbers at index j sums up to the target value. And if it is, we'll be able to return this array. It'll be I plus 1. Remember that the array will have to use 1 base indexing instead of 0 based indexing, like we use here. So that's why we use this here. Okay? And then just because Python does like to return errors if there's not a return statement in every single case possible, we're just going to return the empty array. Which shouldn't happen, but Python will not pass this program without return statement in every single case. So that's why this is there. Okay. And then time complexity. Yeah. All events squared. Sure. It is a constant space-time complexity, which is what we want. However, notice it's the n squared time complexity because of the nested for loops. Oops.
How far is Albany?
Yeah, so we're definitely going to want to change that up a little bit. So, without further ado, let me introduce the next solution.
No, did you ever make the mod bit? I'm jump roping and then running back.
Well, let me introduce the next solution. Alright, so.
Some more until I feel like I'm going to.
Alright, so we loop through the numbers again. We'll have left and right pointers, basically. At the element afterwards. And the last element. Respect. Okay, so just to be clear, this is not exactly two-pointer solution.
Oh, shit.
Solution. This is actually a binary search solution. This is their solution. We're basically taking like middle values between the left and right pointers, and then using that to find the target value that we want. If we're able to find. So we're gonna have a temp variable, which as
you're gonna be pod ghosts when they send Odin into space with satellites, right?
As the target value minus
oh shit.
The number at index I. Alright, so this is the value that we want to find using binary search, basically. Alright? Now, we use another while loop, so while L is less than or equal to R.
Well, what I'm running.
Alright, so while the pointers do not overlap, basically, okay, we'll have a mid value equal, which is L plus r minus l all divided by 2. So we're basically just taking the distance between the right pointer and the left pointer, basically, and then taking the middle element and then compare.
I downloaded
here. And we can stop if this mid value is the target value that we want to find.
So, like, you put your weight in your reps.
Neat.
And
then we should be able to return the array as such.
Based on how much everyone had, like, their weight lifts, ratio, and it'll, like, on that lift on the type of,
all right.
On bench press on time and 3.
Now if that doesn't work, well, we need a secondary check as well.
Like I have a
we'll need
level bicycle crunch.
So
I have
if our middle value basically is less than the value that we want, we'll need to increase our left pointer basically and repeat the loop again. And then there's the other way around, where if the number at our middle value is greater than the value that we want, in this case we want to decrease our right pointer. And then lastly, because our Python program will not allow this program to run without a return statement in all possible cases, we'll need an empty return array. All right.
I want to make my name something bad.
So.
Oh shit! Wait.
All right. So let's. All right. So this is an O n log n time complexity. So, because many of you probably have not seen binary search before, I'm going to explain a little bit more how this works. I didn't really touch base on it too much, just because I was still trying to write the plan out. But it's kind of similar to the two-pointers problem we saw on the last problem that video that I wrote 2 months ago. So yeah, we do left and right pointers basically, but all we're doing is checking the range of values from either the left pointer to a mid value, or the mid value to the right pointer, depending on where our target value is. So because we have this little halving section, we're basically halving our search by half every time, which works because this array is sorted. It's only going to take log n time complexity to perform the search, and then determine whether the search was successful or not. And then the worst that's going to happen is that we have to do that n times. So our time complexity is going to be n log n. Alright? So, pretty cool solution. A little better than the brute force solution. However, I will admit, we might be overcomplicating this a little bit too much. So we're going to try one more time and just use the simple two-pointer solution. All right. So let's see how this works.
Yeah.
All right.
Thank you.
So left and right pointers as 0 and length numbers -1, respectively. So we have a left pointer starting at the first index, and this right pointer starting at the right index. Basic two-pointer setup. And then we want to loop through until the two pointers overlap, basically. Which hopefully will not happen, because otherwise there wouldn't be a solution. And if there was this case, we might have a problem with our code, actually. So we have a current sum equal to the numbers at each pointer. Okay?
Yo, wait, Liam, invite me back.
And then we want to adjust our pointer variables depending on what the sum is. Alright, so we want to check if the sum is greater than the target. Because there are values, then we need to decrease our sum. And then because if we decrease our sum, we will want to decrease our right pointer. One. Alright? And then if the current sum is not target, but instead is less than target, we want to do a similar thing. We would want to increase or increment our left pointer. And then there's the last case where we actually have found our target. Sorry. Being a little loud.
I literally just came up with that on the spot. On the spot, I just thought that.
Alright, and then
well, because my name at first was.
We want to return the left pointer and the right pointer. Add one to each because we are still using one index in here. Alright, and then we want to make sure we have the empty array returned still. Because again, Python doesn't like it if we don't handle all the cases. Alright, so we have O of n time complexity and the O of 1 space complexity. I think this is sufficient enough. And this should work because the array is sorted, which does help us out a little bit.
Yeah, no, you're.
And we should be able to, and because the array is sorted, if we were to decrement our right pointer, values should decrease, except for for the case where we have repeated values. And then if we increase the left pointer, we should have an increase in the value from there. There.
No, that's dope.
And it should always return a solution in this case.
Like Liam.
So let's write out the code and see if this actually works. We're going to start out by initializing our left and right values. So it'll be 0 and length of numbers minus 1. Just so we can properly get the last index. And then while left pointer is less than right pointer, we just keep looping through until we find the sum we want. We'll add the elements at each pointer.
No, I'm just because you guys know. Remember the code.
We will decrease our right pointer if current sum is greater than target.
When Donovan. Pizza.
And then the current sum is less than target. We want to decrement. We want to increment our left pointer.
No, just tell.
And then if all else fails, we have found our solution.
That's why I'm not saying. Yes.
And then, of course, we need to return the empty array case. Alright? This shouldn't happen, but we need it to run Python. So let's try running this, see if our template applications pass.
Okay.
Perfect.
Basically,
alright, so let's submit.
I had a really good weekend.
Alright, it looks really good. So, yeah. Excellent time complexity, excellent space complexity.
Oh.
2 pointers is definitely the best solution that is required for this problem.
Okay.
Alright, so yeah, I guess this is it, guys. Thanks so much for watching. Watching this program. Again, I apologize for it taking so long to do this video.
Jason Dillon recorded.
I'm glad to be back at it again, and I'm ready to keep working on preparing for all these technical interview problems, helping you guys out too with this stuff. All right. So again, thanks again, folks. So long.